Hello, welcome to our CPAT technical capsule. Today we are going to review the proper way to set up the DSG1 in an all-digital CATV plant. The objective of this exercise is to determine the optimum CW QAM level offset, or delta, between the adjacent QAM channel digital power level and the maximum peak level of the injected DSG1 carriers. The delta value is required in order to configure the DRV3 detection device with the proper detection level parameters. In this exercise, we will be using 132 megahertz, with an output of 50 dBmV from the DSG1. Take note to always set the output level of the DSG1 to 50 dBmV in order to later attenuate the signal to achieve the proper level. Since we need to make digital and analog measurements, ideally you could use a QAM analyzer such as the AT2500RQ or equivalent. If this equipment is not available, you may also use a QAM SLM signal level meter and an analog spectrum analyzer such as the HP8591. For this particular exercise, we are using a divisor QAM analyzer, which will allow us to see both the power of the adjacent QAM channels and the spectrum analyzer screen of the injected carrier. In order to make a proper measurement, you will need to find a test point after the downstream combining so you can measure the QAM channels together with the injected DSG1 frequencies. You will need to make sure you have enough level at the test point to make a valid MER measurement of that QAM channel. Typically, you should have at least a -5 dBmV signal for a 256 QAM channel. Before injecting the carrier from the DSG1, begin by making the QAM power measurement of either of the two adjacent QAM channels. Record the digital power level and also the MER as your baseline. In this example, we are injecting at 132 megahertz, therefore we are measuring the adjacent channel at 135 megahertz, and we see that we have a power reading of -4.5 dBmV and an MER reading of around 37 of MER. Now to inject the DSG1 signal. With the DSG1 set for 50 dBmV output, calculate the loss through the combining network in order to obtain approximately -18 dBc from the digital power level recorded previously. Set your spectrum analyzer to the selected frequency, in this case 132 megahertz, and set your analyzer to 2 megahertz of span and make sure there is 30 kilohertz of resolution bandwidth. Inject the DSG1 carrier and use a marker on the center frequency to make a measurement, remembering to put the analyzer in peak hold in order to obtain the maximum peak of the DSG1 carrier. If necessary, fine-tune the attenuation to obtain the nominal delta between QAM and DSG1 carrier. The objective would be to set the DSG1 signal as high as possible while maintaining acceptable MER degradation. In order to verify this, simply go back to your SLM measurement after injecting the carrier and make sure that the MER has not degraded. As you can see here, the MER is staying at a constant 37 or 38 MER, so there was no impairments being caused on the adjacent channel. Repeat this process for the second injected DSG1 frequency and record its values. To complete the setup, what we will need to do is to set up in the CPAT web the CW QAM level offsets for the DRB3 detection devices in the field.